With regard to questions of procedure, we thought that at this stage the best idea would be to begin by asking each of our guest speakers to explain very briefly their position on the problem of the conflict between determinism and indeterminism. A moment ago, Professor Landsberg suggested that it might be worth forcing the question about the definition of each of these options. We would like to ask our speakers to relate this definition explicitly to the concerns, we might say, of the non-scientific members of our audience. That is to say, we would ask them to consider the problem not so much in terms of the conflict between determinism and indeterminism as the conflict between necessity and freedom in a general sense. Immediately after this round of definitions, we will hear the 5 interventions that have already been requested, and then open the debate directly to questions from the floor, as in a normal debate. If everyone agrees, we will begin in this order.
Well, I don't mind starting if you want me to. Well, the question is, where do we stand on the problem of determinism? And I have I'm a very old man, and so I have a very long experience of some problems. And my experience is that when there has been a long discussion, avid and agitated of 2 opposing points of view, that then there is something to be said for both of them, and that the proper solution is probably a compromise. And I have such a compromise on this question. In fact, I could say I have a modest example of a compromise. I believe that we think, well, the free will, first of all. It's a slightly different problem, right? Is it part of it? Free will problem? That we have free will, everybody thinks they have free will, but in some way, maybe to an outsider, if he is very well informed about this person who thinks he has free will, this outsider may think he is actually acting as a result of many earlier influences, and so is really not an automaton, but something perhaps similar to it. That's the view I want to put forward for the moment. I may change it. Now, that's the first point about free will. Now, about indeterminism, Professor Tom and also I both talked about gambling a bit. And I think we both said that when you control all the movements, you know, remember I talked about the croupier, and Professor Tom talked about shaking the box with the dice. If that is all completely understood and controlled and all the equations are known, then of course you know the outcome. And then there is no chance anymore. And so I am inclined to say that indeterminism does not exist in the following sense. Things happen. That's it. Things happen, and there's no alternative. There's one movement forward. So that's for the moment, just to give my friends a chance to think a little longer.
Would you like to?
That I agree. Things happen. That was also the starting point of my talk. I had used indeterminism or determinism in the sense of a physical theory. A physical theory has a deterministic dynamics. If it is possible to prepare the trajectories in the sense that I can reproduce the same trajectory. Or the physical theory has an indeterministic character. If I cannot prepare the same trajectories, for instance, I can only prepare the same frequencies for various trajectories. That was my definition of indeterminism or determinism of theories. And that makes only sense if, as you say, the facts are there.
Perhaps Professor Tom would like to.
Well, I think that among all comments which I received after the talk, the one about the precise definition of determinism, namely, do we require for a deterministic approach a uniqueness of solutions and eventually uniqueness involved satisfying some extra condition like continuity with respect to initial data or things of this kind. This is perhaps one of the most basic problems of determinism in science. Would you consider a solution which would bifurcate into two solutions, for instance, as escaping really from determinism, passing from one solution to the possibility of two solutions? Would that already be something?
Such a theory would be, in my sense, indeterministic.
Indeterministic.
Because the solution is not, the laws of the dynamics is not deterministic.
Yeah.
Not deterministic.
But if it happens, but something will, in real life, the system will go either one way or the other. And in any one case, the system has chosen.
This was...
To say it in an example, if you have a system described by a deterministic dynamics, but there is something like catastrophe or so, then I would, as physicists, say that the theory has to be made more comprehensive to describe for instance, the probabilities for the various cases. That the deterministic description, as physicists, is not so good, is unreal in this case. For me, that's my opinion, that I cannot prove it.
If you consider, for instance, the problem of the Riemann-Hugoniot.
We can take the simple example for the simple example you had given of the pendulum in the highest position.
Yeah.
Then I have two trajectories, on the left or on the right. And then I would say in the neighborhood of this point, I have to change the theory. I have to, for instance, by thermodynamic oscillation theory, to get probabilities for the various experiments. The deterministic theory is, as I say as physicist, not as philosopher, is, I mean, not realistic for this point.
It's a question of definition, of course, and there is no point in discussing.
I would like to speak from the point of view of an astrophysicist. That is to say, a field in which you do not have experiments. You observe by different tools in different wavelengths with different resolving power in wavelength, in time, or angular resolution. And we have a large number of observed facts which we have to interpret and to understand. And the basis of our work is, first of all, the assumption that there are laws in nature and that the laws which are driving the phenomena in celestial objects are the same as the laws which are discovered on earthly experiments. But furthermore, it is impossible in practice to do any kind of work if you do not assume, even as a pragmatic way, that there is a deterministic effect which is in action and determines what we observe. That is to say, either the detailed properties of the objects or some statistical properties. And I would like to give as an example of the long run between completely deterministic situation as in the old meaning of the word deterministic to cases which are entirely accidental. That is, take the case of the solar system. When you speak of the sun itself, it is a big body with a large number of atoms, and you can describe it, at least globally, by classical hydrodynamics and rate of transfer of radiation and so on. It is completely deterministic object. But now if you come into the generation of the solar system, you discover that the solar system has left behind about 1,500 small bodies of the order of 10 to 1,500 kilometers, the asteroids, and already there, any statistics is beginning to lose any meaning. Now, if you reach the question of the planets themselves, you find that they have a very strange distribution of distances to the sun and of rotation and direction of the axis of rotation. And this is probably the signature of some accidents which took place during the formation of the solar system. But when I say accident, it's because I have no better words to describe these things. In fact, these accidents have been completely deterministic in the sense of mechanics. But there are so few events there that we cannot speak of any kind of statistics. Next time, when we have observed 1 million solar systems in the galaxy, we'll be able to speak of statistics. But this will be for 100 years from now.
I come from a very different field, biology. And apparently one's profession, as has been said here, conditions one's philosophical attitudes. In this case, a biologist cannot get away from seeing him or herself as just another organism, and from wondering whether these issues of determinism or indeterminism are not related to the ability to survive. Because it is through natural selection that the characteristics of the human person as a thinking and conscious being have been achieved. The biologist also tends to see systems within systems, a small system enclosed within a bigger one, and so on. From this point of view, I also recognize that the attitude of science is fully deterministic. With an indeterministic attitude, it would probably be difficult to elaborate a precise science of analysis. Nevertheless, the data that are usually analyzed in biology are always limited to a very small domain, and indeterminism soon appears. Unforeseen facts appear.
Evidentment, la solució és molt senzilla.
The solution, obviously, is very simple. It's enough to broaden the domain of observation until the phenomenon in question, unexplained in more limited conditions, is finally comprehensible.
En certa manera és una conseqüència de la nostra ignorància. Però si anem pujant de nivell...
In this case, one is clearly dealing with an apparent indeterminism, which is a result of our ignorance. Problems of this type are inevitable. They arise as we raise the level. And of course, we mustn't forget that we ourselves are a tiny system immersed in a much larger one. Thus, we come up against the issue of the limits of the explorable universe. Something always remains that is undetermined within this explorable universe, but which is explainable from outside. The limit itself, of course, is not too precise. So the idea comes close to Popper's conception of the open universe. For this reason, it is true that the scientist adopts a deterministic position for practical purposes, but precisely because the limits are constantly escaping him, or rather because they are shifted by the scientist's research itself, he is also aware of accepting effective indeterminism over and again. I would also like to mention another issue which I believe has become muddled during these discussions. As an aid, I will take the two columns presented by Dr. Tom, which I myself have used. For the biologist, these two columns represent the chicken and egg problem mentioned by Dr. Wagensberg, in the sense that often they have a connection that we might call genetic. The biologist deals with complex systems that usually follow an evolution which is sooner or later interrupted. This evolution may be the succession of a natural system, like from abandoned field to a wood, from egg to chicken, and so on.
O altres processos que són fàcils d'imaginar, representen una seriació de...
And it represents a seriation of states in which two different situations are distinguished. At the beginning of such a sequence, one can usually make a relatively short description. This is the case when scientists can apply quite simple and clear mathematical models, the typical equations of growth, multiplication of individuals. This first situation corresponds to the deterministic model. But with time, a different situation is arrived at. When the elements that were able to react among themselves have already done so, when not so much free energy is left for new reactions, then there is what we might call a historical accumulation of information, and description becomes extraordinarily difficult. This is the moment when the danger of abusing language arises, for example. Here, uncertainty has been introduced. What is happening is that things have apparently not been able to keep a precise record, and the scientist, of course, does not understand it and gives up the attempt to construct any kind of route. To us, the system looks extraordinarily confused, and we usually call it undetermined or chaotic. It seems to me that the two columns reflect these two situations quite well. The second situation is the one where a lot of people talk about chaos, the undetermined situation. I believe that this idea is perfectly valid from another point of view, because generally when a paradox exists, there is a contradiction.
La discussió es pot allargar indefinidament.
And in this case, we say it is a contradiction between determinism and indeterminism. The argument may go on indefinitely, and possibly what should be done is a synthesis, trying to get up to a higher level. The leap from determinism to indeterminism may seem a lot like this concept of the shift from a highly determined to a very complicated situation. For example, the progression from the first scientific description we make of the development of an organism, the colonization of a field, etc. When we have the organism made, and this organism is able to receive perceptions from the outside, it may develop individual characteristics. For example, it may be the carrier of cultural characteristics, which are not inherited. I wonder whether we shouldn't take this small axis of different situations a bit further, whether what we call determinism is nothing more than an abstraction, a simplification, which, moreover, is very human. We abstract the processes we see every day and give them a form that is simpler for us. And so I wonder whether indeterminism may not be a situation of despair, when we are faced with these very complicated situations, where a very complex system has formed, which, in turn, is able to process more information. It may be that if our thinking following this axis, guided perhaps by these intermediate stages in biology, we might clarify these concepts a little more.
And now the first person to request the floor is Dr. Santos. I was going to begin by referring to something that Dr. Wagensberg said this morning, which was that one's profession, or one's particular discipline within science, may have an influence on whether one is a determinist or an indeterminist. The mathematician tends to be a determinist, and the biologist an indeterminist. As has already been mentioned here, there is a connection between determinism and science or rationality. This was just to support an idea already expressed here, that there is a connection between determinism or science and rationality. The scientists of the 18th and 19th centuries were dazzled and surprised to find that nature could be described, in the sense that predictions could be made about future things. It was something that had not been achieved until then. So determinism took on a positive aspect, predictability, and a negative aspect, fatalism. Predictability became the basic characteristic of science, and above all, of technology. It is what enables us to build reliable instruments and equipment that we know how they are going to work. Over these centuries, science evolved precisely in the direction of greater predictability, with determinism as the guiding light. And so the tendency seemed like an asymptotic approach to maximum rationality. An increasingly greater degree of determinism was sought in the law of physics. With the formulation of quantum mechanics, the 20th century put paid to this dream, and I believe that precisely due to quantum mechanics, this century has turned out to be less deterministic, the age of the rediscovery of irrationality. After this general comment, now I would like to refer more to determinism in classical physics and in quantum physics, as there are some points I should like to elucidate. In the first place, to say that classical mechanics is deterministic is an extrapolation. I believe we need to talk about the determinism of descriptions, not the determinism of the world. One thing is reality and another the determinism with which such reality is described. Determinism is a property of theories and requires two conditions which in all rigour never come about in practice. The systems have to be sufficiently simple and isolated.
que es cuando se tiene sistemas suficientemente sencillos y aislados. Pero precisamente
But classical physics is applied to macroscopic systems, and such systems are never, by definition, simple.
no son nunca sencillos. Y otro problema es que tampoco
And their isolation is always an idealization.
es una idealización el que los sistemas están aislados. Entonces, si uno tiene en cuenta la complejidad de los sistemas,
So, when one wants to take the complexity of systems into account, that is to say, when one wants the description to be more complete, stochastic elements need to be introduced.
eso que no se ha descrito
And so the deterministic theory has become indeterministic.
clásica de un
In brief, classical physics is also indeterministic,
habría que introducir
when it suits.
los estocásticos que harían que la descripción pasara de ser determinista a ser indeterminista. Por consiguiente, quiero decir que son las descripciones
Let this first comment serve to break with this tendency to associate determinism
de
with the classical theories.
hacerla determinista o indeterminista, incluso dentro de la física clásica. Eso era un poco por romper
To break this connection, which seems to be evident between determinism and classical physics.
de la física cuántica, donde
Secondly, I will refer to quantum mechanics. In this case, as is well known, there is no indeterminism in equations.
a mí me parece que la situación es más complicada.
Equations are deterministic.
Como es bien sabido, el determinismo no está en las ecuaciones. Las ecuaciones
The indeterminism is in the process of measuring, in the postulates of measurement added to the equations.
que se añade, podríamos decir, a las ecuaciones. Pero eso da lugar a
All this gives rise to a paradoxical situation.
que si se tiene un sistema,
In effect, a system that evolves without being observed
mientras el sistema
evolves in a completely deterministic way.
sin observación evoluciona de una forma
If, on the contrary, it is observed, then it stops being deterministic.
observa
The reduction of the wave packet comes about.
la reducción del paquete de ondas. Pero si el
And if we consider the system plus the observer as a new system,
entonces
then this system obeys Schrödinger's equation
sería a su vez determinista.
and would in turn be deterministic.
Parece que es una situación paradójica.
This paradox illustrates one of the strangest aspects of quantum mechanics, which divides physicists into two camps:
Que opina quizá lo que
those who believe quantum mechanics is a reasonable theory,
tal vez es que
and those who believe it is not.
no tiene remedio, que hay personas a las que la mecánica cuántica le parece perfectamente razonable y hay otros
Possibly reaching agreement is very difficult.
que durante muchos años
Einstein and Bohr, for example, went on arguing for many years without ever managing to convince each other.
no estoy satisfecho con la mecánica cuántica.
Personally, I'm not satisfied with quantum mechanics in its current state, and that is why I will not venture to state whether the indeterminism produced or predicted by such a theory is or is not essential.
Que para mí la teoría fundamental no existe todavía.
I believe that we have still not hit on the fundamental theory, a theory that will replace the one we are working with now.
Pues yo lo centraría quizá recogiendo
What is the central problem of quantum mechanics? A few days ago, an appealing analogy came to me.
una proporcionalidad.
It consists of comparing relativity and geometry on the one hand, and quantum mechanics and logic on the other.
En ese sentido, la relatividad lo que puso
General relativity brought one thing into question: is the geometry of the universe Euclidean or not?
la geometría euclídea o no. Y entonces se llegó a la conclusión de que la geometría, de que cuál es la geometría del mundo.
The conclusion was clear. It cannot be taken for granted that the geometry of the world is Euclidean. This is a property that should be subject to experimentation.
Es
And it's true, relativity is to geometry the same as quantum mechanics is to logic.
la mecánica.
The problem is that quantum mechanics is not compatible with classical logic.
Es una afirmación quizá
This statement will seem to many people to be going too far. And the truth is, it needs to be qualified in many respects.
ahora y vamos a dejarla simplemente.
But let's stay with the idea.
Lo que quiero decir es que la física clásica se basa en una lógica que suele llamarse lógica clásica, que es una lógica distributiva o booleana, que se llama también.
Classical physics is based on an equally classical logic, Boolean distributive, while quantum mechanics is based on a propositional, non-distributive calculus.
Proposicional de la mecánica cuántica no es distributivo. Bueno, eso es una cosa un poco técnica, pero se traduce en el hecho de que los valores de verdad de los
This translates into the fact that the truth values of the propositions are not simultaneously determined for all the propositions.
si no se da, por lo menos pensamos que se puede dar. que puede ser que no sepamos cuál es el valor de verdad de una cierta proposición, pero no porque no esté definido intrínsecamente. En cambio, la mecánica
In
cuántica...
classical mechanics, even though it does not occur, we think at any rate that it can occur. That is to say, perhaps we don't know the truth value of some proposition, but not because it is not defined intrinsically.
Esto es la situación que es más extraña. Bueno, quizá esta situación...
By contrast, quantum mechanics is incompatible with the fact that the properties of systems are defined in themselves. They are defined in connection with a particular experiment.
En el teorema de Bell lo que se hace ver claramente es precisamente que la mecánica cuántica es...
This situation has been shown very clearly through Bell's theorem, according to which quantum mechanics is incompatible with what some call a realist theory, others call a theory of hidden variables, and which I prefer to call a theory of distributive logic.
Entonces, ha habido unos experimentos que se han realizado, en particular los experimentos de Aspect, que hay una opinión generalizada que se ha manifestado esta mañana de que han demostrado, sin duda ya, que cualquier teoría con lógica clásica...
Quantum mechanics is irreducible to any theory with classical logic, which in addition is a local theory. This morning an opinion that is very widespread has been expressed, that it has now been proved beyond any doubt that any local theory with classical and local logic is incompatible with observed experimental phenomena. The arguments for this statement are based above all on Aspect's experiments. Well, I wish to state that I do not agree with it. Basically because the inequalities that have been contrasted with Aspect's experiments are not those of Bell, but others deduced by various authors such as Closet and Chimeny, which include additional hypotheses as well as realism and locality.
Es decir, el hecho de que lleguen dos fotones a dos detectores simultáneamente. Entonces, en esas desigualdades siempre aparece en un miembro las probabilidades de los sucesos simples mayor o igual que una combinación de probabilidades de las coincidencias. Entonces, cuando las eficiencias son bajas, resulta que las probabilidades de las coincidencias son mucho más bajas en general que las probabilidades de los sucesos simples. De tal forma que las desigualdades de Bell genuinas, que son siempre las que mezclan estos dos tipos de...
It would be too technical to reason this out in detail, but I will say that Bell's inequalities do not violate Aspect's results, but remain within a more than acceptable scale of 100 to 1.
Es decir, que están muy bien satisfechas esas desigualdades. Entonces lo que pasa es que se han deducido otras desigualdades que comparan unas coincidencias con otras coincidencias, pero para deducirlas es necesario hacer unas hipótesis adicionales, que es un tema un tanto técnico en el que no entraría ahora, quizá no es el momento de entrar, pero simplemente diré que esas desigualdades se basan pues en el realismo.
In my opinion, the violation of these other inequalities signifies, precisely, the violation of that additional hypothesis, which seemed very reasonable, but which apparently is not.
Dr. Doe has the floor.
I wanted to make an observation prompted by this morning's speakers and by the discussions that have followed. I believe, in effect, that the question about the validity of determinism or indeterminism in the subatomic world is a meaningless one. If it were possible to formalize theoretical physics, this question would be well raised by a well-made formula. From what we have heard here, one deduces, I believe, that this well-made formula within theoretical physics is precisely an unsayable formula in Gödel's sense. That is to say, the question is to define a new axiom, or better, a new law of physics.
Dentro de este sistema de la física es una fórmula precisamente indecidible en el sistema de Gödel. Fundamentalmente porque creo...
Very good arguments have been given, in the current situation of physics, in favor of a profound indeterminism that affects the very nature of subatomic particles.
Un indeterminismo que afectaría a la naturaleza misma de las partículas subatómicas. Por otra parte, también nos han dicho cómo siempre es posible que haya un parámetro, unas variables ocultas, lo que sea. Y si uno tiene en cuenta además que sabemos tan enormemente poco, que hay todavía tantas
If, in addition, we take into account this possibility, which we have also been told about, of new parameters, like the hidden variables, and the still immense possibilities of the subatomic world, promises of new discoveries and new lucubrations, one is inclined to think that physics, the current physics of course, always has the last word, but that a scientific decision on this subject is probably one of the cases of unsayability predicted by Kurt Gödel.
Entra dentro de los casos previstos por Gödel de indecidibilidad. Parece que sería una solución.
Dr. García Doncel has the floor.
Yo querría hacer alguna indicación sobre el
I should like to comment on the historical origin of indeterminism in relation to quantum physics. Because when the subject was presented this morning, I feel that there was not enough insistence on its scientific motivation, giving the impression that determinism springs from the preconceptions of the various authors. My thesis would be rather the opposite. Many of the leading players were led to indeterminism in spite of themselves. As we've just been told, in classical physics, a vague determinism held sway, which may perhaps simply be the inheritance of the Aristotelian notion itself of science as knowledge of the necessary and not of the contingent. This vague determinism is accentuated naturally in mechanicism, which arose from the elaboration of Newtonian mechanics. And it is in this context where the intelligence of Laplace belongs, an intelligence able to know the positions and speeds of all the particles in the universe at any given instant, which is impossible, would know all the past and all the future of the universe. Classical field theory, which reached the end of the 19th century, does not discuss this determinism at all, nor does the relativistic revolution. What does, though, is so-called classical statistical mechanics. In it some indeterminism appears. Let us call it gnosiological, related to ignorance of the microscopic detail of the phenomenon, which, however, permits a global calculation of the phenomenon at our mesocosmic scale. The question of ontic determinism came to maturity in the decade prior to the quantum conceptual revolution and its statistical interpretation. In my opinion, the first to formulate the subject was, oddly, Einstein, when in 1916 he introduced the coefficients of the probability of absorption and emission of radiation of an atom. He did this with a mentality of classical statistical physics in order to deal with a certain microcosmic ignorance. But all the effort of the old quantum mechanics that sprang from Bohr's atom consists of explaining these parameters by the quantum structure of the atom. Arriving thus at a statistical conception of quantum phenomena. Niels Bohr undoubtedly exaggerated this statistical view in his famous article of 1924, with Kramers and Slater, in which he statistically relates the corpuscular world of the atom and the wave world of radiation. This is a desperate attempt to escape to another dilemma, the wave-particle duality.
Aquí hay, diríamos, una exageración, quizá una salida, una escapatoria para otro dilema, para el dilema onda-corpúsculo, de solventarlo de una manera estadística.
As is well known, in 1926, Max Born introduced the probability amplitude in his study of collision problems within the new quantum physics, which was the heir to Heisenberg's matrices and Schrödinger's equations. So it was affirmed, for the first time, that we cannot predict specifically where a particle will go after a collision, but only what probability it has of going from one place to another. This is the statistical interpretation of quantum mechanics for which Born received a late Nobel Prize. Quantum indeterminacy was corroborated with Heisenberg's famous article on impression relationships in 1927. These relationships spring from an analysis of the most precise possible experimental measurements and give a lower quantum level to the product of the experimental errors with which the pairs of magnitudes called canonical conjugated are measured. In this same paper, Heisenberg discusses so-called causality, that is to say, determinism. Laplacian determinism, he says, according to which, if we knew the present, we could know the future, is false. And not because the consequence of this conditional syllogism is false. We cannot know the present with the precision demanded by the mechanicist mentality, since the initial conditions are canonical conjugated, and the errors in them are limited in quantum terms by the uncertainty relations. In this same context, Heisenberg wonders whether such indeterminism is gnosiologic or ontic, and responds sensibly that an ontic determinism, radically undetectable by possible experiences, would be useless. Starting from these clearly philosophical considerations of Heisenberg, the indeterministic view was elaborated, which was presented the same year, 1927, at the Como Congress by Niels Bohr and at the Solvay Congress by Heisenberg and Born. This was what would be the core of the so-called Copenhagen interpretation, the orthodox interpretation which served as the basis for discussing the Einstein-Podolsky-Rosen paradox of 1935 and Bell's inequalities of 1960. For me, this introduction of indeterminism by Born, Heisenberg and Bohr does not spring from some chaos-inclined mentality, but simply from the fact that they are unable to explain quantum phenomena in any other way.
Es una puntualización muy rápida. En mi opinión,
a brief point. In my opinion, today it no longer makes sense to talk about the Einstein-Bohr debate, or its current continuation around the Copenhagen interpretation, in the context of a discussion on determinism or indeterminism. I agree that Bohr and Einstein focused their dispute on this topic, but everything changed radically, first in 1960 and then again in 1970 as a result of two papers by John Bell.
Se demostró que la confrontación entre las dos interpretaciones, digamos, la que representaba Bohr y la que representaba Einstein.
In the second, less well known than the first, Bell showed that determinism is not an essential property. An indeterministic theory that was in addition real and local too contradicts the orthodox or Copenhagen interpretation. What is at issue is realism and locality, not determinism and indeterminism.
Al lenguaje quizá un poco más vulgar la localidad física por la causalidad, que no es el determinismo. Una segunda puntualización, una última puntualización.
So, even while believing that aspects experiments are conclusive, they would still negate the possible existence of an alternative to quantum mechanics in the Copenhagen interpretation that was simultaneously real and local, the two things, because such are the hypotheses of Bell's theorem.
Simultáneamente realista y local, las dos cosas, porque esas son las hipótesis del teorema de Bell. Por tanto, queda incluso admitiendo los
This means that the possibility of non-local realist theories and of non-realist local theories remains open.
Si bien, naturalmente, sería dudoso.
Finally, I want to say that in this debate, we should take quantum mechanics as the currently valid theory, which is what it is, for the sole reason for which theories are in general taken as valid in the course of history, because they are successful in all the systems to which they are applied, and because there are no better ones.
I very much like Dr. García Doncel's intervention from an historical perspective. I should like to bring out a little corollary, which also has a bearing on the comments of Emilio Santos. In effect, as Dr. García Doncel has said, indeterminism has existed in physics since Max Planck discovered, it was an empirical discovery, the first quantum discontinuity.
La primera discontinuidad cuántica. He dicho que es un descubrimiento empírico porque, como nos recordaba, aunque en otro contexto.
This was in 1900, and Planck arrived at it in a totally unexpected way, as his concern was the interpretation of black body radiation.
Inesperada para él es a través de una interpretación de la ley de la radiación del cuerpo negro. Bien. Se puede decir, este hecho,
No one better than Niels Bohr understood the fact that indeterminism appeared with the first quantum discontinuity.
No lo entiende nadie mejor que Niels Bohr. Yo creo, de hecho, que es.
And I believe that this is his great contribution to physics.
Hace unos meses ha escrito un libro de un filósofo estadounidense, Falls, en que pues, demuestra de una manera bastante erudita este hecho. Bien. Vuelvo a la línea de mi argumentación.
Therefore, indeterminism can be said to exist in the physics of the microcosm a long time before the wave function collapse postulate appeared.
Que aparezca el postulado del colapso de la función de ondas. Mucho tiempo antes. Entonces, si tenemos esto en cuenta, vamos a pasar ahora a parte de la argumentación.
A few minutes ago, Emilio Santos pointed out that Schrödinger's equation is a deterministic equation. However, he went on to say, wave function collapse adds a radical, dramatic element of indeterminism to quantum mechanics.
El hecho de que de alguna manera la ecuación de Schrödinger es una ecuación determinista. Sin embargo, dice él, añadía a continuación, tenemos que el colapso de la función de ondas añade un elemento radical, dramático, indeterminista.
I believe that this in some way, I couldn't say where, is incorrect, because, as I've already said, it had already happened a quarter of a century before. And so I find certain doubts entertained by philosophers of science quite reasonable. Maria Bunge, for example, points out that the wave function collapse plays no fundamental part in quantum mechanics.
En algunos filósofos, fundamentalmente filósofos de la ciencia, que también algunos físicos, en el sentido que
if a problem exists, this is the problem of measurement. There is no theory of measurement in quantum mechanics, not even a theory of measuring equipment.
Problemático en la mecánica cuántica es realmente el problema de la medida. No hay una teoría de la medida en la mecánica cuántica en el sentido.
I don't know if I entirely share this point of view, but to maintain indeterminism in quantum mechanics without resorting to the wave function collapse seems to me to be a good way to go. The problem of Emilio Santos is a real problem, to be sure, but it somehow fails because quantum mechanics has to be indeterministic, even without resorting to such a postulate. This is proved by one of the few basic experiments in quantum mechanics.
problema real, el de Emilio Santos, ciertamente, pero falla de alguna manera, porque incluso sin postulado la función de ondas, la mecánica cuántica debe ser indeterminista. Es uno de los pocos experimentos básicos de la mecánica cuántica lo demuestran.
Yo quisiera matizar que se ha dicho.
I would like to make some distinctions. It has been said several times here that in mathematics there is determinism. And clearly, of course, within a given formal system, leaving Gödel's theorem for a moment, within this system, in effect, there is determinism.
Sistema efectivamente hay un determinismo. Pero mi cuestión es la siguiente. Se ha dicho, por ejemplo,
But my question is this. This morning it was said, for example, that natural numbers are there and are given. But I'm not so clear about this. I'll give you an example solely to fine-tune my question.
Esta duda mía. Imaginemos el teorema.
Let's imagine Fermat's great theorem, which might be solved positively or negatively tomorrow, but it will be solved by virtue of an auxiliary axiom which, if we accept it, may solve it positively, but if we don't accept it, or we accept its negation, may solve it negatively.
Nos lo puede resolver, o si aceptamos su negación, nos lo puede resolver negativamente. En este sentido,
in this respect, I am saying that it's not so clear that we can establish determinism in maths.
El determinismo en matemáticas. Quizá pondré otro ejemplo.
Perhaps I should give another example. If we accept the axiom of choice, real numbers have certain properties in respect of the Lebesgue measurement. But if we accept the axiom of determination, these same real numbers, I no longer know if they are the same because we've accepted another axiom in set theory, have other properties in respect of the Lebesgue measurement. I don't know if this was the previous Lebesgue measurement, because in fact I am in another theory. Then from this standpoint, I say that I don't know if mathematics is so deterministic. Within each formal system, it is. But as a science, I don't know. This is a doubt I have brought up here for debate, if there is a debate.
A brief intervention on the comments of Joseph Pla. When I spoke this morning about Gödel and determinism, I wasn't referring to what I thought. I agree with Pla. But to what Gödel thought.
Yo me refería a lo que pensaba Gödel. Y Gödel, él pensaba que había una
And Gödel thought that there was a very clear difference between the world of natural numbers, which is perfectly determined in all its aspects, including hypotheses like Fermat's or Godbach's, and what our algorithms allow us to decide.
lo que nuestros algoritmos nos permiten decidir.
Gödel thought that this was a flaw in our algorithms and our formal systems. And obviously there is a difference between the fact that a certain portion of reality has certain properties and the fact that we have available an automatic mechanism to find out whether effectively it has these properties or not. Nevertheless, I believe that the problem of determinism or indeterminism is a little contrived in mathematics, because this is a problem that is raised basically in terms of time, which is a non-existent concept in the world of mathematics. It would be more natural to raise similar problems in terms such as decidability or undecidability, in terms of completeness, whether there is a single system of axioms for set theory or many alternative systems of set theories, etc. But I suppose there is no time for further discussion.
I wanted to begin by giving my opinion on how the world round has gone, particularly at the table. With few exceptions, reference has been made, as Professor Santos has said, more to scientific knowledge, and the problem which ultimately has brought us together here has been largely avoided. And I suppose that tomorrow the debate will continue. I think this is partly because the people who have spoken today are from scientific areas of quite pure physics, not very complex systems. And tomorrow, Independently of any definition we give of complexity, we are going to have deterministic or indeterministic ideas closer to human emotions.
Más cercanas a las emociones humanas, digámoslo de esta manera. Claro, es evidente.
Of course, it is obvious that a scientist whose job is to search for laws will be a deterministic in method. We have said this several times this morning. But I believe that a little care should be taken when it comes to extracting philosophy from this. I believe that, at any rate for me, a false impression has been given, which is that in the existence of laws and in the existence of determinism, the view that nature is deterministic is favored, or at least it bears the weight of demonstration. For example, since the leap is equally valid when one departs from the law and talks about one's particular view of the world, I believe that if, for example, we use any definition of determinism, for example, equal causes produce equal effects, and we vary those causes in the world equal, once again we have the old problem of infinite information. Two equal things, two identical things, means that we also need infinite digits for them to be equal. If we make small variations in the causes, we have small variations in the effects. Determinism functions. If slowly varying the causes, suddenly there is a leap in the effects, then we are in the problem of stability. For me, there is now a signal of suspicion, of indeterminism. And I rather like the idea of the world that emerges from here, because not only is it a coexistence between laws and zones of indeterminism, but one which works quite well for me personally, emotionally. And the intervention of indeterminism or the intervention of chance is punctual, and in the continuous zones there are laws that we could certainly admit as deterministic. This small opportunity of a group that mathematicians may call zero measurement, because they are only points where chance may intervene, and all the rest for determinists fits perfectly, and I believe it is perfectly possible to juxtapose the word determinism with the words freedom, creativity, and everything that comes next. That is to say, that this image of a universe outside science, we are now talking about beliefs and ideologies, is another universe which has at least the same rights, another vision of the world which, apart from saying that things happen, according to whether we observe them before or after they have happened, gives a different vision of the world, even though it departs from science.